Hi, in this video, I'm looking at graphing trigonometric functions and what the graph of these look like. So basically I'm asking, say, for y equals sine of x, what would the graph of that look like? Now, to answer this question, we actually really need to have a look at how these are defined on the unit circles. So if I draw a unit circle, so I've got the vertical axis, horizontal axis of the unit circle, and let's put the circle on there. So let's see if I can draw a reasonable quality circle. It's more of a squircle. And so let's have a look first at what the units on this circle are. So the x meets at 1, and the y meets at 1, and we get -1 and -1. So the intersection points of my axes are at 1 and 1 and -1 and -1. And so if I want to go and translate this circle onto a graph for y equals sine of x and think about what that's going to look like, I'm going to draw the axes over to the side. I'm going to have a look at what happens. So if I get my vertical axis and I get a horizontal axis, the horizontal axis, which is our x-axis, is given to us by how far we've rotated around the circle, because this is normally an angle in here. So it's the angle of rotation around the circle. So if I start off with, the origin, we've got 0. And then as I move around the circle, I'm going to be increasing my angle. And so when I get to here, I've got an angle of 90 degrees. But we typically do this in radians. So if I make, say, this point here be the radian equivalent to 90 degrees, which is pi over 2. And as I keep moving around the circle, I'll reach this axis, which is 180 degrees, or pi. And if I keep going around, I'll get to 3 pi over 2. And if I keep going around, I'll eventually get myself to 2 pi. And it keeps going. I can just keep revolving around. So I get around here, and, well, I can now have 5 pi over 2 is the next time around. I could have also gone backwards. If I went back to here, I could have gone negative, and that's going to be a rotation of negative pi over 2, because we went backwards by 90 degrees, or backwards by negative pi over 2. Keep going backwards, and we'll go even further backwards and go negative pi. And these can keep going in either direction, but this is as far as we'll go. So now if we start thinking about the graph and what can happen, I need to know how tall I can get. Well, let's start at a 0 rotation. Just think about, where am I at 0 rotation? So if I'm at 0 rotation, it means I'm on this line here. I'm on the x-axis of the unit circle. And if I think about what sine gives me, sine, I know we've got y equals sine of x here, but if we go back to the definition of sine, for if, say, I have a right angle triangle on there, where we've got our angle of rotation, sine gives us the vertical, which is the y, because it gives us the opposite over the hypotenuse of 1. So it gives us the y-coordinate of any point on the circle. So if I start here, at 0 rotation, I've got no vertical height. I'm on the x-axis. So that means I actually started with a point at the origin. And as I move around the circle, I get more and more and more and more height until I reach this point here, which is a rotation pi over 2, which means that I've got a maximum height of 1. So if I put that there as a maximum height of 1, that's as far as I go up. And then as we go back around the circle, and I get closer and closer to the rotation of pi, I get closer and closer to the x-axis. I start losing vertical height. So I'm back down here at 0 at pi. And so what we've done is, as we've gone around the circle, I've gone up and we've gotten to 1. And then we've come back down and we've ended up at pi. If we keep moving around our circle and I move around here, I move below the horizontal axis. I start getting into negative numbers. And so I get down here to -1. So at 3 pi over 2, I'm all the way down at -1. So if I put on my -1, then I'm going to be down here at -1. So when I've reached pi over 2, I'm down here at -1. which means that then as I keep going back around, I'm going to get back and back and back and back, and eventually I'm going to come back to 0 at 2 pi. So it comes down, and we reach -1, and we curve back up again. Let's see if I can do that slightly better. We come down, and we curve back up again. And then I can keep revolving around. So if I keep revolving around and I've done another 90 degrees, I'm going to be back up here at 1 at 5 pi over 2, which means I'm going to come up. And it would drop back down again. And that would keep going forever. And it's the same if we go backwards. If I start back at 0 rotation and rotate backwards, if I go backwards 90 degrees, I'm going to end up down here at -1. And if I keep going, I'm going to circle back to 0. So I'm going to come down and up. And of course, this pattern would just keep on going and going and going because we can keep revolving around this circle. So these graphs are infinitely long, but only end up between 1 and -1. So this is the graph of y equals sine of x. It starts at the origin, 0, 0, and at 90 degrees, a pi over 2 has moved up to a value of 1. Then back down at pi, it's back at 0. Then at 3 pi over 2, it's at -1. At 2 pi, it's at 0. And that pattern keeps going. 0 up to 1, down to 0, up down to -1, up to 0, up to 1. And it's cyclic. It's this oscillating cyclic curve. So let's have a look at another trig function. So let's have a look at cos. What happens if I want the graph of y equals cos of x? Well, if we go back to our unit circle, so we can use it to help us. So I'm going to have my unit circle, and it meant that we have a circle. That's a bit better than my last one, where I've got 1, 1, -1, -1. And let's put on our axis. So I've got my horizontal axis, and we'll have our vertical axis. And let's put on our rotations. So let's have pi over 2 and pi and 3 pi over 2 and 2 pi and 5 pi over 2. Oh, look, we'll even fit in a 3 pi before we run out of space. Then going backwards, we've got -pi over 2. And I'll just give myself a little bit more axis to play with so we can squeeze in -pi. So let's have a look at what happens to our graph. If I think about cos x, going back to the definition, if I rotate it around an angle, because we get the adjacent side with cos, it's going to give us the x-coordinate of any point on my circle. So I want to know, as I revolve around the circle, what's the x-coordinate of the point that I'm at. So if I start at no rotation, I'm here on the x-axis, touching at 1. So when I'm at the origin here, I've got a maximum height of 1. And that's actually my starting point as well. I actually start off, no rotation means I start off at 1. As I revolve around the circle, I'm going to be on the y-axis now, which means I'm at x equals 0. Because I'm on the vertical axis, that's when x equals 0. So at pi over 2, I'm at 0. And if I circle around to a rotation of pi, 180 degrees, I'm at an x-coordinate of -1. So I'm down here at -1. And so at pi, I'm meeting at -1. And if we keep going around, 3 pi over 2, I'm going to have gone back to the y-axis, so that's an x of 0. And if I come back around full circle, 2 pi, I'm back up at 1. And if we revolve around again, I'm going to drop back down to the y-axis, back down to 0, and then come back to -1. And so as I've been revolving around the circle, I've been doing this motion. My x-coordinate is moving from 1 to 0 to -1 to 0 to 1 to 0 to -1 to 0, and it keeps that cyclic pattern going. And it would be the same. If I go backwards around, I'm going to start off at 1. I'm going to reverse back around by pi over 2, and I'm going to come back down to 0. And if we keep going around, I'm going to come around to 1. And then that will curve back down And it'll just keep going and going and going. Again, it's infinitely cyclic, again between 1 and -1. But the difference is with sine, we started at the origin because we start on the x-axis, so there's no height. With cos, we start at 1 because we're starting on the x-axis, and cos gives us the x. We're away from the y-axis. We actually got some distance away from the origin. What about tan? What would the graph of tan look like? So tan's a little bit harder to work with, but it's still possible. So if we go back to our unit circle and we draw that on there, we're going to need a little bit more work. So if I think about the definition of tan, because it's called the tangent, because it's defined as if I've rotated around by an angle, it extends until it reaches this line here, and that's the value that tan returns. So if I want to graph y equals tan of x, I've got to think about what's happening on this line. So if I start drawing my axes, just that I've got a place to be, we don't need it to be quite that long, but we'll use it. So if I again have pi over 2 and pi, and 3 pi over 2 and 2 pi and 5 pi over 2, and then we'll get to 3 pi here. And again, negative pi over 2, negative pi, and that'll be fine. So if I think about what's happening with tan, well, let's start at 0 rotation. If I'm here, I want to know what's the vertical value on this line where I meet. So the vertical value is 0. So tan starts off at 0. And as I rotate around the circle, I'm going to get a bigger and bigger and bigger number. So we know that it's going to be increasing, but it actually increases rather slowly. It sort of starts off, we're a little bit away and then we're away. But look how up here, as I get really close to pi on 2, my number's going to get really, really big. And what happens at pi on 2? If I'm at 90 degrees, pi on 2, I'm also on a vertical line. So I'm parallel. I never actually reach that line. So this tan is not defined at pi over 2. It actually has a vertical asymptote. So it goes up and gets very close to that line at pi over 2, but never touches it. But then as we keep moving around, it starts off really, 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 really big and gets smaller and smaller, but does it? Because remember, if I'm up here with this rotation of an angle, tan actually tells me the value down here. So I actually start off really, really negative. So I actually start off down here and I cruise on down. So if I actually start on my axes, tan starts off down here, and as we get further and further around, we get values down here. So if I've rotated to here, I'm over here. If I get back to pi, shooting through, I'm back at 0. So at pi, we're back at 0. So this asymptote's there at the negatives and then comes up and touches 0. So we come up sort of like that. And then as I get down here, as I start rotating through here, because we go back through the origin again, all my numbers are positive again. And when I reach down here, I'm again on a vertical line. So we have another asymptote at 3 pi over 2. Tangent actually has these asymptotes, and the pattern repeats. Every 90 degrees, we have an asymptote, and every 180 degrees, we have 0, and we asymptote between the two of them like this. So we're just going to keep on going forever with this pattern. And it's the same in the negative. If I've resolved around negatively, I'm down here, which means I've got another asymptote in the negative direction, and we asymptote down here. And I'm going to have the same asymptoting happening forever and ever. So tans are a little bit different. Sine and cos, we get this nice oscillating cyclic pattern, okay? But as we get into tan, because every 90 degrees we're on this vertical line, we actually end up asymptoting every 90 degrees, or every pi on 2. So pi on 2, then 3 pi on 2, 5 pi on 2, and negative pi on 2, there's a vertical asymptote. And every pi we have, so 0, pi, 2 pi, 3 pi, negative pi, it's at 0, and we asymptote from negative to 0 to positive. And so there we have it. This is the graph of y equals cos of x, sine of x, and tan of x.